So this is the IETF notebook. I hope you are already very familiar with it. Here, I would just like to emphasize that we work as individuals and try to be nice to each other. So today we have a fully packed agenda with 3 working group drafts, 5 individual drafts, and 1 operational presentation by Rai Shimizu-san from Lai, Japan. Due to the tight schedule, each speaker get 10 minutes except Jane. So I would like to request that all speakers observe
Xi
your
Ping, do you
time.
want to start it up?
Ron, can you hear us? We already started. So here is the status of V6OPS. So in terms of working group draft and individual draft, we are making progress. In terms of number of attendees, the number of attendees are basically stable. We'll see if we can do something to attract more attendees. And you may ask, why do we care about the number of drafts and number of attendees? It's because we want to attract more people to contribute to IPv6. In addition to the draft, these numbers, we really want to motivate more company to deploy IPv6, to propagate IPv6 knowledge, to improve IPv6 support from the devices and solve the operations issues. So these are the main tasks of V6OPS. And if you have any suggestions, please come to Ron and me and have your suggestion. Since we have the previous call for contribution, we made some progress. So first, regarding Brian Carpenter's free IPv6 textbook for college students, we believe that this is a very meaningful piece of work, because if the college students are educated about IPv6, our industry will get a better supply of IPv6 experts. So far, we got 9 contributors and 293 commits. So again, I encourage everybody to check out the link and also become a contributor. The next thing is what Nanili and Mike are leading on solving the IPv6 issue for enterprise. Currently, Mike and Edward are working on BCP. So again, if you are interested to get involved and contribute, please come forward. Also, we want to summarize some of the repeated debate in V6OPS, 6-man, and NANOG. There are certain IPv6 issues that come up, again and again. And we really want to document the result to avoid this repeated debate. Currently, 1 draft has been submitted, and Nick will present it later. We also want to start some of the useful working group drafts. Again, there's one that Jody is going to present later. So these are some of the progress. Again, if you have good ideas, how to make V6OPS works better, please come forward. And this is the chair's part. Given the tight schedule, let's switch to our first speaker. Chongfeng, the floor is yours.
Okay, thank you, Chair. Can you hear me?
Yes.
Okay, thank you. Hello, everyone. This presentation is about the framework for multi-domain IPv6 only only network and IPv4 as a service. Thank you for giving me this opportunity to present on behalf of the courses. This draft is based on the belief that IPv6 will be the centric protocol network in the future. Next, please. This draft was firstly submitted in January 2022. It proposed a framework to provide end-to-end IPv4 service delivery over multi-domain IPv6 only underlay networks, and improved data forwarding efficiency by eliminating unnecessary IPv4 IPv6 conversion in a scalable way. In this new framework, each P will be identified by at least one IPv6 mapping prefix. It will also have one or more associated IPv4 prefix, which are extracted from local IPv4 routing table or mapping related between IPv4 block and IPv6 mapping prefix is called mapping rules. In this context, the mapping rule can be transmitted across the domains. It gives a direction and egress IPv4 service data delivery in multi-domain IPv6 only networks. This draft was firstly presented in IETF116 meeting, and it was adopted after IETF115 meeting in London. And the current version is working group document 01. Next, please. During the call for adoption process, now the comments and suggestions have been received, and most of them are very valuable. We really appreciate that. And nearly all of them have been addressed and sent in the mailing list. And I will give a brief introduction of the revisions based on the comments one by one made since IETF 115 meeting. Next, please. In section 2, based on the comments of Vasylenko Edward, underlay is added to the definition of IPv6 only networks. And based on the comments of Edward Metz, the following sentence is added in section 5. Also in section 5, the term IPv4, IPv6 in the following statements has been changed to IPv6, IPv4 to make the illustration more accurate. Based on the comments of Brian, the format IPv4 embedded IPv6 drive in section 6.1 have been corrected, and this is an example. And based on the comments of Edward Metz, the consideration of integration with the transition mechanism at the UECPE, such as 464 Xlate, has been put in a separate section, that is section 7. Next, please. Drew proposed to make the header title short, so we change it to multi-domain IPv6 only underlay. Several terms below have been optimized to make them more straightforward. In addition, the following terms has been expanded on their first appearance in this draft. A couple of needs has been fixed as well. Next, please. So the next step, we will make further refinement to improve the whole document, and we are still looking forward to receiving more comments and suggestions as usual. Next. Thank you. That's it. Question.
Go ahead.
Okay. I'm Xing Li from Tsinghua University. I'm also the co-author of this draft. So if you have any questions, I'm on site, can answer. Also, we are with Dr. Xie, we have a joint draft on Thursday morning IDR. Actually, some kind of implementation of this. Thank you very much.
If no further comment, let's move on to the next presentation is by Xu Ping and Chong Feng, and it will also be presented by Chong Feng.
Okay.
Go ahead.
Okay, thank you. The second presentation is about operational issues with processing of the hop-by-hop option header. This document, I will give a brief introduction of this document. It describes the processing of the hop-by-hop option header in current routers from the aspects of standards specification, common implementation, and the default operations. It also gives the reason why the current hop-by-hop option has not been widely used in current networks. So next, please. Yeah, this is a history of this draft. It was firstly proposed in October 2020, aiming to trigger discussions on solution for reasonable processing of IPv6 HBH operator header, and enable deployment of HBH operator networks. This draft was adopted in October 2021 with after extensive discussions and support. It also keeps synchronizing with the draft being progressed in 6 months. The first one is IPv6 hop-by-hop operations processing procedure, and the second one is limits on sending and processing of IPv6 extension header. The draft version 02 was reviewed by the authors of a solutions draft in 6 months and achieved significant improvements. Then draft 03 was reviewed in the mailing list and collected comments and made another revision has been made. The current version, the latest version is 04, and it further reflects the comments in the mailing list. Next, please. Right now, we think that this draft is mature and right for entering the next stage. We would like to ask a working group to consider the working group last call of this draft. Thank you. Any questions?
So we will probably take the last call issue to the mailing list.
Okay.
Any other comments? If no, thank you, Dr. Xie, for saving us some time. I think that we really need the time.
Thank you.
So we'll move on to Jordi's presentation. Oh, I'm sorry. Warren, please go ahead.
There we go. I just wanted to make sure that there was somebody who was taking minutes. Somebody asked me off list if we had done that, and I didn't remember at the start of the meeting if we made sure there was a minute taker. Did we get a minute taker at the start of the meeting? Maybe I missed it. Sorry, excuse me.
Okay. So yes, Jordi.
Okay. Everything standing for RN for 1 minute. We need a minute taker, right? Do we have one?
Yes.
Okay, perfect.
Okay, so this document was in last call, I think about 1.5 years ago, but expired for many complex reasons to explain now. So we decided to work again on it. This version has very few changes from the previous one. I will explain in the last slide why we have not done so many changes. Next one, please. So basically, the problem is that in IPv6 only networks, when using NAT64, if there are devices which are IPv4 only, and we have content delivery networks or caches or things like that, the traffic will be translated unnecessarily from IPv4 to IPv6 and then back to IPv4. So this is a disadvantage compared to using carrier grade NAT. Next one, please. So this is the typical 464 XLAT deployment. Next one, please. And what happens is that if we have an IPv6 capable device, all the traffic will be going from the starting host to the destination CDN using IPv6, no translation at all. Next one, please. However, in the case of an IPv4 only device or application, what will happen is that it may be translated in the NAT46 at the CPE, and then back at the NAT64 in the ISP network, so it can reach the content delivery network. And this is not making sense, of course, because we have already done a translation to IPv6. So next one, please. If we can use that translation to IPv6, then we can achieve this optimization. Okay, so that's the goal of this document. Now, next one, please. We have studied in the document 3 possible approaches. The first one is a DNS routing-based approach. And the main issue with this approach is that it needs the CDN or cache providers to do something, okay? This is actually the way they do with IPv4, but when we were asking to content delivery networks if they will be happy to do something similar for IPv6, they said, in principle, not. So it seems that this is not the best approach. At least it was the case when we asked it to the most common CDNs. Next one, please. The second approach is using a table, an automatically built table in the CPE, okay? So because most of the time the CPEs are doing the DNS proxy, we can work on a solution based on that. And this is the main point of the document, and we believe that is the right solution. Next one, please. So there is here an example. I am not going to invest too much time in the example. Next one, please. There are additional considerations because we believe that this is the best approach. So we did a lot of work on looking into different possible issues, and if we believe that they are already resolved on with this second approach. Next one, please. The third approach is having the ISP to provide the translation table instead of being developed internally by the CPE itself. So that's an approach that also has different issues like the increase in complexity, and we believe that it's not worth the effort that it requires from the provider. Next one, please. And this is the set of questions that are open from the discussion from the previous version. Okay, so one of the questions that was raised was optimization should be disabled by default. We believe that not, because in the document is very clear that if there is no 464 XLAT being used, the optimization, of course, is not enabled. Okay, that's the first one. The second one is if there is no NAT64 discovered, is also not enabled. I think some of these questions were from Eric and some others from Jen, I believe, mostly. There were some questions also from Edward. So if they are here, I see 2 of them here. They can probably remember that conversation. There was another point about clients ignoring the TTL in the translation table. And actually, in our opinion, this don't really matter because the TTL is being used by the translation table, so by the CPE. So even if the clients ignore it, the translation or the optimization will not actually be done. There was also a comment about consumer electronics, like I believe it was the Chromecast using alternative resolvers. That's supported. That's something that we already discussed. And then there were some issues about additional security considerations. We believe that the mechanism that we are proposing is not actually increasing the security problems that exist already when you are using a proxy DNS or something like that. And I think that's all.
Jared.
Not working? Yeah.
This one's working. Jared Mach, Akamai. There, that's a little clearer. The thing that I'll comment on your proposal number 1 is that this, the CDNs, we're unlikely to use any sort of network that goes and does some, touches the packets, because the support issues that we'll run into in actually interacting with the ISP around that and how it allows our servers to be used and leveraged. I don't think very many service providers actually want to sign up for that problem space of actually debugging that. We see a lot of transient network issues that cause us to go and reroute stuff. And the public internet is actually has proven to not be very good actually for doing the cache fill or cache hierarchy as well, which has resulted in us building private networks, I think, as many people have seen in doing this. And so we've taken control over a lot of that in order to ensure that we actually get the operational performance that's necessary to keep our customers very happy. So it's unlikely that a proposal like this, even if it were deployed, would be able to be used by many of us, because we would actually likely end up bringing our own solution to not have to go through some intermediary layer, and also go and the support issues that any provider would create for themselves by doing this is going to be extremely high, because you're going to have to understand a lot about, for example, our own application behavior and such, which is, it's unlikely that we'll share all of that.
But if I understand you correctly, you mean approach number 1?
Correct.
Yes. Yeah, that was my point, that in the case of CGNAT, you are actually allowing private space to come directly to the caches. But in IPv6, we don't have that solution. So approach 1 is not good, and this was our point already.
Yeah.
So we agree. Thank you.
Warren.
Sorry, it takes a few seconds for audio to turn on. So this document was expired for somewhat more than 2 years. It's now been revived, but I think that the chairs should confirm to make sure that the working group is still interested in working on it. I mean, it had been sitting idle for so long that I think it's worth triple checking that.
Yeah.
Jen also had some comments on, have all of the outstanding issues from the second working group, from the working group last call actually been addressed, but I'll let her ask those.
Okay, thanks, Warren. I will talk with Ron about this later. Eric?
I think I still have when the draft was still active, there were a lot of discussions and concerns around the option 2 portion, and I think a lot of those issues. I think you did a great job addressing a bunch of them, but I think there's a number of those that are still significant issues, and I think the thing that worries me the most there is really the support issue risks. I think we'd want some experimental experience with this to really kind of work through some of the issues. I think there could be a lot of corner cases that when we do experiments, we'd start showing up there. And if this did start getting deployed in that option 2 range, at a wide scale basis. I worry that it might cause brokenness and support issues, which might then cause CDN customers to try to switch content back to IPv4 only. And I also it has been a few years since we were talking about this last, and there has been progress on at least to some degree on v4 only clients. So it may be that at some point, by the time this got implemented, it may be that the number of v4 only clients becomes small enough that this becomes less valuable than it would have been a few years ago.
Thank you.
Hi, Jen Linkova. Yeah, to be honest, I still need to recall exact list of issues we were talking about last time, but I did look at the diff between the versions, and I have some concerns that I do not see much difference between the text, so I am not sure all concerns were addressed. Also, I totally agree with Eric. I am not sure that how much of the problem we are trying to solve here, right? And also, who actually interested in solving this? I mean, is it CDN who wants to see traffic not being translated, or is it ISP trying to reduce amount of double translations? Because obviously, I would expect that who's gonna suffer from this if it does not work? It's users and probably ISP support. So it would be interesting here to see like some data on how much of problem we're actually solving, because I do anticipate on CPEs, because CPE has always been a problem with V6 deployments, right? It's exactly where bugs are. So you're adding this, which is rather complicated, non-obvious, and failure scenarios would be very exciting. So I'm still a bit concerned about this, to be honest, right, from operational perspective. And so, yeah, if you could give us more data or more details about how we go and address those concerns, that would be great. Thank you.
Yeah, actually, the main problem why the document was stuck is because we had two CPE vendors that agreed to provide samples of this, and it never happened. So we waited and waited, and we never got that. But we know that's something that commonly happens with new transition mechanisms or things that we ask to the vendors to improve. So that was the main reason. And the reason there is not big differences is because when we look at the inputs from the previous document, we were waiting for the samples from the CPEs. We realized that we basically, as authors, we don't agree with some of the comments. They were already resolved in the previous version, so that's why you cannot find too many changes with the TIF, obviously. Now, if we think that any new protocol change takes time in the market, yes, we agree, and this is always the problem with IETF in general, that anything that we try to improve, it's going to take time, but it's very difficult to consider if it's still an advantage considering the time versus how much the progress in the market will happen, because it's not the same in Europe or North America, where the CPs may be replaced sooner than in Africa or Latin America, for example. So we need to take that in consideration always. Finally, your point about what it was. Who is the advantage of this is basically for the ISPs, because some ISPs are telling us we prefer to use carrier-grade NAT because in carrier-grade NAT we don't have this overload for the CDN's traffic because we have a direct solution. But if we use IPv6 only, we don't have that solution. So they prefer to stay with carrier grade NAT, which is not what we want, right? We want as soon as possible to go to IPv6, right? So that's the thing.
Yeah. Masanobu.
Hi, I'm Masanobu from NEC Platforms. Long time no see, George. Anyway, I will support this draft, and I prefer to approach 3 to approach 2, because approach 2 has an issue, because if end user use public DNS server, it's a kind of trouble, right?
Is resolved.
Yes.
In the document is explained how that is resolved as well.
That's why I prefer approach 3. Then, do you have any, as you said, CDN cache provider needs to provide API to update EAMT?
You need for approach tree?
Yes, yes.
Yeah, we considered that was not easy, and
Do you have any ideas about the API?
we will need
Okay,
to talk again with
yeah.
CDN providers
I
to
have
see if
some
that's
idea.
affordable.
Yeah, I have some idea.
Yeah. Okay.
So anyway, we need to find the more practical use cases, right? Okay, let's discuss.
Thank you.
Okay, thank you.
Hello.
Edward,
Yeah,
I'm
Edward.
sorry, the queue is already closed.
No, not for me.
So, Ron, do you still want to say something? Just now you were in the queue.
We can talk offline. Thank you.
I would suggest that we get a sense of the room as to how much interest there is in this draft.
Okay, then. We move on to the next speaker.
Oh, could you hear me?
Yes, Ron, please.
Yes, could we get a sense of the room as to how much interest there is in progressing this draft?
I think he said, could we get a sense of from the room about how much interest there is on this?
Okay. We can do a quick poll.
Yes. Please raise your hand if you are interested in working on this draft, either reviewing it or. I can't see the results. Can you?
Ron, it's Tim. It's 16 to 14 right now. We can see it in the room.
Okay. Okay, let's move on.
Okay.
Okay, this is a draft about doing prefix delegation in the home. So next slide. I think I wrote this last time during the last IETF, so I haven't presented here yet. So the real problem statement we have here is we've done a really good job getting prefixes larger than /64 from ISPs to the edge router. So the prefix, the topology here is there's an edge router in your house from your service provider. Typically, you can bring your own too, but they're there and they're getting these large prefixes, but they're not getting beyond those routers. So what's happening today is a lot of them sit there, they get the prefix and they're allowed to assign it to guest networks or other networks they have connected, but it doesn't go beyond that. So this draft is trying to address that problem. Next slide. So this is the typical topology. So this is what is happening today, I would say, is we get a lot of really nice IPv6 routers that get /56s, /60s, /whatevers. They get those addresses, and then the guy below it plugs in a typical IPv6 7084 router, whatever little v6 router you have in your home. This matters a little bit more now with IoT networks as well, where they would just take a device, plug it in, it requests a PD, and then it doesn't get one back because the ISP device is not doing prefix delegation on its LAN interface. So it gets no answer, so that really should be a frowny face at the bottom. He has no v6 connectivity. It's sad. So I wanted to go over this really quick because this has come up a couple of times with this draft. So there are two models to solve this problem. We went down this road a very long time ago for those who are familiar with HomeNet. We talked a lot about this. There were some drafts. None of it worked out. That was, I don't know, 10 years ago, a little bit less. So I just wanted to talk about what the two options are. Hierarchical is taking large prefixes and breaking them up And basically you have to put rules in the CPEs to tell them how to do this, whether it's take a /60 to break it up, take a /56, depending on what you get, this algorithm gets pretty complex. And we've not seen, or at least I have not seen anybody attempt that other than the Cable Labs guys. They do have some going on there, on the DOCSIS in particular in the US. What this model proposes is what we call flat. So in this case, the ISP router is the only one, or the edge router in this case, is the only one that's going to be giving out prefix delegation. Everybody else is going to be getting it from that edge router. Okay, so this is the really simple one. I've got a couple topologies coming. This one's really simple in that, in this case, you just basically turn on IAPD on the LAN, it answers it, it gives out a /64, global V6, we're fine. Go to the next one. This one should be pretty straightforward. The next one is where it starts to get interesting. So in this case, you have two routers, they're connected somehow directly underneath the device under test. I put 7084 routers. These could really be IoT devices, whatever it is. Some router that is giving out IP address. It's not bridging. It's not in a flat mode. It's doing real IPv6. In this case, this one's pretty straightforward. They both put requests for IAPDs, and then the CE router answers them pretty straightforward on the downside. So it still works. Everything's fine. This is pretty normal to most people, most deployments. Okay, here's where we get a little fancy. So the deal here is when you build a network like this, in this case, there's an edge router that's coming from the service provider one. It's going to have a router connected to it, and then the one last router, IoT device sitting on the end. So what we did in the draft, what the draft says here is that routers who are not the edge router should become a DHCP v6 relay. So they should pick up prefixes behind them, pick them up, and relay them all the way up to the edge router, right? So this solves a couple of the problems of being able to support a flat hierarchy where you can have DHCP messages to travel over multiple links. All right, there's a couple, having gone through those topologies, there's a couple of changes here. One thing, obviously the first most important thing here is we want IAPD support to be on the CE routers on the edge. So one thing we should do here is, hey, we should turn that on. The only other requirement we've added to those guys is that they also have to be able to process relay messages. That's not normal for a IPv6 CE router, so that's one thing we're adding. Additionally, a lot of them are going to have to support relay agent. Some of them do now, surprisingly. Actually, this is better supported than IAPD for some reason. I don't understand it, but that's what's been going on. So that's another thing is they have to support relay agents. Those are the major changes we've made. Go ahead to the next one. Okay, so this is for children of my age or people of my age. This is a choose your own adventure part of this. So at this point, we have not touched 7084 proper in quite some time. There's a couple options here. If we want to mess with it, we should go to the next slide and talk about that, or we can just let this draft be an update to 7084 and deal with that problem at a later date. Go ahead to the next slide. So if we want to do a 7084 biz, I would not suggest that we open it for everything. It's been doing pretty well. I do think there's a couple of cleanups we could do. There's a lot of reference. I get a lot of emails about supporting 3315, things that we fixed in 8415. Obviously the 8200 and 8201, there's some other updates in there that we've made along the way. We should just update all of those. What's in the prefix land draft. We should remove the transition text. 9096 does a much better job. We should just take out the 6RD and DS Lite stuff that's in there now. Just remove it and point to the new RFC. And the last thing we should do, because this comes up all the time in CVE attacks, we don't require ingress filtering. So spoofing, the anti-spoofing stuff, it's a should. You'd be surprised how much this would help the internet. So we should add that as a requirement. And I gave myself time for some questions.
Jen Linkova. Thank you, Tim. I did read the draft. I like it.
Oh, good.
Yeah, I don't have any particular opinions about updating requirements or not.
Okay.
And to think about that, but yeah, I think it's a good idea. I'm actually surprised it's not a kind of default behavior already.
Yeah, it's definitely not.
Yeah.
I've only seen it on, we looked at about 30 CPEs we have, and only one of them did this. And you had to configure it to do it. So it's not
So
a
yeah,
great
so
situation.
maybe just my lack of knowledge. I don't know if you need to do anything about like recovery and like reboot scenario and all that kind of stuff, because it's probably the most interesting part.
So this should work the same way that IANAs work, and we should be okay, is my really short answer to this. I have not written that text, but
It should work in most of the cases,
Yeah.
unless it doesn't. Yeah,
I
so-
think if you're in a big hurry, we might have a problem, to be completely honest, right? Some of the timers can be very long, and that's where the problems occur. So I'll put some words around that, and whether we want to do things about that, we can talk about it.
because I think we've seen a number of like issues, and I think there are like all this renumbering draft is actually coming from that problem space, right? So this might be okay when you have dual stack network, because if your V6 does not work, it's fine. But I think we need to be a bit more careful about what we're writing right now, keeping V6 only deployments in mind, right? And making sure it's not acceptable anymore to have like broken connectivity for 5 minutes.
Okay, thanks.
Yeah, Lorenzo Khalili, want to strongly second that. I mean, like, given typical implementation on CPEs and the fact that they rarely get updated, I think we should really have, I mean, ideally open source code that works because people can just copy it. But I think putting all of this in a 7084 BIS is probably not a good way forward. I think like we need to think about the corner cases and, you know.
I'm inclined to agree, and we could deal with that problem down the line, but I did have a couple people ask. But I wanted to throw it out to the group, but I'm inclined to say, let's leave this draft as is, and then if we later want to take on 7084, we could.
I definitely think we should have the 7084 BIS to say that we need to do this, right?
Yeah.
My ISP doesn't do this. I would like to do a V6 on the network. I can't. The other thing is, I guess, what sense do you have? Like, we're basically walking away from hierarchical PD kind of forever. We thought for a while that was the right thing to do. Maybe it's just too hard. What do you think? You've been thinking about this for a while.
I have been thinking about this for a while. Yeah, I think that's the answer. Everybody I've talked to gets scared. They see those equations and they run away, and they're like, we can't do this in a CPE. Well, there's all these cases where it could go wrong, and that's why I kind of wrote this to be, hey, let's go the flat way and see if people will adopt that.
Because you run out of space, right? Okay, thanks.
Tolle Sekert, yeah. I think that every time we're doing a draft like this that doesn't cover, you know, the redundant case with multiple uplinks, we're just reaffirming the fact that people cannot deploy them. So I really love to see the scope expanded to have multiple uplinks to multiple service providers in the same run. And
Okay.
not, let's do that later in another RFC nobody ever adopts.
So Nick's going to present later, and he's going to say some words around this. But in essence, I was worried that we were going to get lost in that discussion for getting PD on the downside was the general gist of this.
David Lamparter, just one thing I wanted to make very explicit. I think you're implying it. The CE router doesn't actually relay things to the ISP, right?
Okay, so somebody wrote me this, and I need to put more words around this. That would be bad, but to be completely honest, it wouldn't hurt anything. But the real issue here is that how would they know that they're actually at the edge of the ISP network?
Okay.
So the answer is it could happen. Every service provider that I've asked about this is very unconcerned about this. They will shoot on site.
It is very unclear from reading the draft.
Yeah. I'll put some words around that. But yeah, it could leak, yes, but it shouldn't damage anything.
So Eric, speaking as the Internet AD and responsible for the SNAC working group that you know, I can tell you this draft is very important for SNAC, again, as you know, and keep it simple.
Yeah.
Right. We need to avoid the HomeNet thing.
Okay. I'm with you. How am I doing?
Masanobu-san, I'm sorry, we have to move on here. Please take the issue to the mailing list.
I think Warren's the only one left, maybe? No, that's it. Okay.
Yes. Nanili.
Hello?
Yes, go ahead.
Okay, thanks. Yeah, I'm going to keep this quick, and then Dhruv will be there to answer questions too. I'm not going to put my video on because I'm frightening. Okay, so let's go to the next slide because there's a bunch of them, but a lot of this is here so that you can look at it later. So let's go to the next slide. Keep going. We've been testing a bunch of topologies from the simplest. Yeah, keep going. Keep going. And then we started really looking at CDNs. We looked at CDNs in detail. Okay, next slide. Because what I want to do, all this stuff is for you to look at later if you want. So basically what we did is we moved our server behind a CDN so we can control it. Okay, next slide. And so this is kind of what it looks like. We have a domain name, it's behind the CDN. Okay, next slide. And so CDNs can do DNS and DNS and proxy, although why anybody would do just DNS is beyond me. Okay, next slide. And so what we did is we tested a bunch of things. So, okay, so I'm going to slow down here a little bit. If you have a dual stacked web server and DNS, a lot of times the CDN is preferring IPv4. It's doing a proxy kind of business. So it's got two different connections. You're coming in V6, and if you've got a V4 connections, it's going to go to the origin server in V4. That's interesting. Okay, next slide. Yeah, and you can see this is just a trace packet, you know, in case you don't believe me. Okay, next slide. So if we took out the V4 definitions, next slide. So we force it to go V6 only. Next slide. If you force it to go V6 only, I mean, take out all the A records, it will go V6, but it won't, the extension headers won't follow. Okay, that's interesting. Next slide. If you do DNS only at the CDN, then you've got a simple client-server topology. In that case, everything works, but you're not doing any proxying at the CDN. If you bypass proxying, you know, I mean, of course, it's like, really, it's like, why would I do that? Okay, so next slide. So really, one of the interesting things is we did some tests before and after. And we're working with two different CDNs. And what we did in November, and in November you can see that they had 31% of the sites responding if there was an extension header. And in February, it was 100%. One of the CDN providers had found a bug in their load balancer code and fixed it. And you can see it is fixed. And so now extension headers are being passed. Next header. Next slide. And same for another CDN. Before, they were not passing extension headers, and now their connections with extension headers are being processed. So the point is, next slide. So the point is we want to see where extension headers can be sent reliably, and CDNs. There are a few major players. CDNs are one of them, which have a disproportionate impact on what happens with IPv6 and extension headers on the internet. And as you can see, two of the CDNs have modified their behavior. To the good, I would say. Next slide. So, should there be a BCP? Should we, I don't know. In some ways, I think all this talk about V6 only, this, that, and the other thing, is kind of interesting considering that CDNs are preferring V4. So anyway, yep. So I'm done. Comments?
Morning, Anthony, Liquid. I kind of said this at the IPG meeting yesterday, but just for those that weren't there. So the main issue here, and I think Warren also kind of elaborated on it quite eloquently on the chat, was the fact that proxies or CDNs are working at layer 7, not the IP and transport layer. So that's why the EH doesn't get all the way through. Now, it does, you've kind of hit the nail on the head with the question of, should we look at a way of signaling to the CDN or a provider to say, hey, we want some EH to go all the way through. But then the question comes is, how do you get that response back? Because again, it's on the transport connection, not the layer 7. So I just wanted to elaborate and just say, you know, the proxy is your problem because it is terminating your connection first. So you can get the response to the CDN, to the end user, but not Origin's CDN.
Yep. You know what? I'm going to be a little bit flip. Those guys are smart. They can figure this out. I'm kind of teasing, of course, but let's just see. I just want to bring up a problem, okay? And you're right. I'm not convinced it's a layer 7. You know what I mean? I think it's more complicated than that, but I think we need to get the CDNs into the conversation. Yeah, I'm just putting this out. Okay.
Eric.
Eric Lycwood, Akamai. Thanks for the investigation you did here. As you noted, we managed to fix one of the issues you found that was causing some packets with extension headers to get dropped. But there are a number of issues getting conflated here, and I think there have been some of the issues with where some implementations have been dropping packets extension headers is a separate issue from do extension headers get through to origin. And the issue with CDNs being layer 7 proxies is a separate issue from that extension headers getting dropped problem. And it's unclear to me that in the case where you have a layer 7 proxy, that sending extension headers through to an origin on a completely unrelated connection necessarily makes sense. There might be cases on a case-by-case basis, but that seems like one where we need to understand it, and that would be part of a kind of product feature integration.
Yeah, no, I'm going to keep this short so other people can talk. There are very definitely multiple issues here. Correct. Yes. Thank you, Eric. Mm-hmm.
Jared Monch, Akamai. I just also want to comment on this. If you've got 2 requests that come in, one with an extension header, one without, and they're asking for the exact same object from the cache, and so you're not going forward to the origin for each one of them, it's not clear to me what the behavior you would want should be for something like that. And so I don't think that there actually is a problem there per se, because you're not always going to preserve the same behavior on the transport on the front side as on the other side of some sort of application gateway.
No, Jared, yes. I think, though, the reason that I'm interested in this for PDM is we're doing response time. If we know, certainly, if we could put something out at the CDN edge and return something back so I get response time, or respond to the header so I have my performance data, that would be great. And we are looking at your APIs and other people's APIs too. And if you could help, I'd love to have a conversation with you offline.
Warren. Thank you. I mean, I guess I'll say what a bunch of other people have said. If you've got a proxy, you've got 2 transport connections. And there's going to be a bunch of different things on that, like different MTUs, etc. So it's unclear what the sort of meaning of propagating an extension header would be, right? Like we don't propagate the TTL or the original packet checksum because they don't make sense. They're a different sort of layer. A proxy works at something above layer 3. And so transporting sort of layer 3 information up to it doesn't really make much sense. If you want to be able to propagate things like EH, what you're looking for then is something that's more of a straight TCP proxy or IP proxy, not a web proxy. I think that that's sort of where this conversation is going off the rails slightly.
Yeah, I mean, Yeah, there's a bunch of different issues. This is complicated. There's a number of things though. As I said, CDNs prioritizing V6 over V4, and there are some CDNs which won't even do V6 to the origin server. So there's three different issues here, and I just wonder if this is something we as a group should be thinking about.
Okay, Andrew.
Andrew McGregor, Fastly. And yeah, we're one of the ones who don't do V6 to the origin. I will say yet. The EH question, you can't pass the EHs through the proxy. But what you can do is make them available to, as most CDNs do, have the ability to run arbitrary customer code in the proxy. You can certainly pass them to that code and make it part of the customer visible API. I think all of these questions, prioritize IPv6 over IPv4, do IPv6 to the origin, and what to do with the extension headers, they're all a matter for customer configuration, and they're going to be customer specific from the CDN. Certainly, we should have the ability to do all these things. And it's kind of embarrassing to be up here and saying this when we don't, but this is all going to be per customer. Now, there are some extension headers, like for performance measurement, that should be pretty standard, and we should by default do the right thing with them, whatever that is. But the others, let the customer choose.
Manili, I suggest that you don't respond. You just take the comment and then think about it. If you need to communicate with Andrew later, the group I've also request that we move on.
Sure. No, sure. Thank you, Andrew. I'll contact you offline.
Jane?
Hello. We presented the draft very briefly, 25 slides per second in London. So let's now spend a bit more time so I can explain the details, what we are doing, why, and how it can be useful. Next slide, please. So let's start from the very beginning. Fundamentally, unlike in IPv4, in IPv6 world, hosts are expected to have multiple addresses. And in most cases, they do. So obviously, they all have link locals. In most of the cases, a host would have stable and privacy addresses. Well, Fernando pointed out it might be just temporary address, but so now, as we start deploying V6 only, we're also adding 464 XLAT address to a host. So basically, you can easily get 4 normally without doing anything special. Then I've been doing a lot of network renumberings, actually. And it means you're basically doubling the number of global addresses for a while you're doing graceful renumbering. So 7. Chrome OS currently, because it's using a lot of virtual instances inside, requires between 7 and 9 addresses to operate normally. And by energy meeting in London, it was an interesting presentation from research perspective about how else we can utilize this fundamental property of IPv6 protocol, having multiple addresses per host. And at the end of the day, we have an RFC which strongly recommend not to limit the number of addresses per host, so we kind of expect hosts have multiple addresses. What does it mean? It's a great thing, but it might come with a cost for a network. Next slide, please. First of all, it does have some scalability implications. Obviously, routers need to maintain neighbor discovery caches, which means 1 entry per address. All this smart infrastructure like switches, access points, do like to track IP addresses assigned to a host for doing neighbor discovery proxy or for security reasons, which means, again, they have those tables, and sometimes those tables are way too small for the number of addresses you can see in the network. Also, if you decide to deploy EVPN, it means you now most likely will have type 2 routes, 1 route per host, per address, sorry, which means you move from before world where you have one route per host, you might have 5, 7, 8, 10 routes for the same number of devices, which actually completely different scalability requirements when you buy hardware. Also, yeah, all this countless discussions we have had about Slack versus DHCP, with the arguments being made about I need DHCP because I need to know what addresses were used by devices at that given point of time. And all these caches I mentioned, right? When a device could not put an address in a cache, we create a very unpredictable failure scenarios when some addresses on device work, some don't. If you're using virtual environment, it's very unpleasant to troubleshoot, speaking from experience. So next slide, please. So what do we have now? We have host requirements on one side and network operators being a bit unhappy about this situation on the other. What can we do? Can we actually do something which would make everyone equally unhappy? It's a definition of rough consensus, right? So we have a proposal. Next slide, please. People wanted to use DHCP, let's use DHCP. But let's use DHCP prefix delegation instead of address assignment. What we are suggesting is host can request /64 and y/64, I'll tell you later. And typo, okay. So a network can delegate the prefix to a host, and host can use that prefix to assign as many addresses as host needs to its interfaces, or actually even to any downstream or internal systems connected to that host, which basically we're doing the same thing as we do in IPv4 using NAT, but without NAT. Great, right? Next slide, please. So before, how it works now, right? Let's say I have a phone, I have a machine with host operating system and a couple of virtual machines. And obviously, we're going to have a lot of entries in the neighbor cache, or, as I said, in access points, for example, IP to MAC address tracking tables. If we move to prefix delegation, those two devices on the slide, each would get its own delegated /64, which means for network infrastructure, we're now moving to one neighbor cache entry per host for link local addresses and one route per host for delegated prefix pointing to link local address. So now we're basically scaling to a number of hosts, not number of addresses, which can be like 10 times smaller. Next slide, please. Let's talk about benefits of this, as someone told to me, revolutionary approach. So scalability, as I said. Now I can scale my network, which means buying hardware, to the number of endpoints and not the number of addresses. Next slide, please. Second benefit, potentially, not immediately, is that we have a chance of eliminating neighbor cache exhaustion attack, because it's a well-known problem, right? If you have directly connected /64 configured on the interface, if someone is trying to scan your network, router will have to create incomplete entries for every address being scanned, and potentially you can exhaust the cache, which actually impacts the hosts which are already on the network. So now let's imagine for a second that all hosts in the given segment supports prefix delegation. Well, I have such examples, my corporate network, internal Wi-Fi, which only corporate managed devices can connect to. I know operating system on them. I know what they're capable of. I can eventually get to the situation when all of them support the feature I need. In this case, I can actually remove global /64 from the interface completely. I'm using link local, and I'm using prefix delegation for every host. So basically, there is no directly connected hosts. There are no directly connected global addresses on the given link. So there is no risk of scanning attacks here. Next slide, please. Accountability. So yes, now we have an ability to track, know from the DHCP PD service which prefixes were delegated to which host at every given time. Obviously, we can get the same information currently from Slack by getting the neighbor cache data. I played with telemetry. It's very dynamic by nature, right? And it's hard to get all that amount of information right away. Jared, do you want clarifying question? Okay. So basically, we're getting the same benefits we have in DHCP-v4 by using prefix delegation in terms of tracking addresses to device mapping. Next slide, please. File sharing. So now we're avoiding the situation when if some hardware or software limitations are exceeded, some addresses might work and some don't. To be honest, it's much better from my perspective as an operator to see the device fail completely than seeing some subsystems on that device to fail randomly, unpredictably. This is exactly what's happening if you get Chrome OS, for example, on a Wi-Fi network, which limits IP to MAC number to low number. So something starts failing, then starts working again, failing again. It's very hard to troubleshoot. In this case, you have a prefix. All addresses and that prefix share the fate routed the same way, work the same way. Your device either works or not. Next slide, please. Extensibility. When about 2 years ago, I presented how we migrated the whole guest network segments across all our offices to V6 only. And for wired network, the maximum, the largest number of complaints I got was about the scenario, oh, I used to plug my device into the network and I had some testing private network behind it and I was using NAT. So from my perspective, that device was actually just a single host, while actually it was something behind it. And it stopped working as soon as you remove V4, unless that connected device has some form of 464X slot or something. So basically what we get in with delegating /64 is the ability of extend the network the same way we are doing in IPv4 world, but without doing that. Next slide, please. And by the way, on the mailing list when we discussed this, I don't remember who was that. Someone said, I don't want routers to be connected to my network. I don't think we can reliably make that claim now because you actually don't know. You cannot tell the router from a host nowadays, right? For example, we have like some kitchen equipment which look like a host. I took a screwdriver, opened it. It's actually a router with 4-port switch inside and a couple of tablets connected. So how can you tell without physically opening the device? So the most discussions we got on the list was about why /64 for very simple reason. All devices, all V6 only capable devices are supposed to support Slack. Slack currently works with /64, right? It requires /64 to forward address. To be able to extend the network behind the host without changing Slack logic on all connected systems, you need /64. That's simple. For those who are concerned about, oh my God, we're going to run out of IPv6 address space, the draft has some calculations referring to RFC already published, which shows that for any large network, you most likely should be all right. And again, this does not mean everyone needs to do this. So next slide, please. So yeah, this is, it's not like we're suggesting for every network to deploy it immediately. The networks which would benefit from this most are large ones, when large number of hosts multiplied by a large number of addresses introduce some scalability issues. So like large enterprises, large hotspots like conference networks, system networks where there are a lot of virtual machines running on hosts. Obviously, it might not be a problem at all at your home network. In your home network, you might be actually more concerned about address space because your ISP gives you /60, so you can only have 16/64. But on the home networks, you don't have this scalability issue. If you have 25 Chromebooks with 10 addresses, it's still okay. So next slide. So obviously migration plan. What's going to happen if I have a device which use normal Slack from PIO advertised by router and a device which doing PD? What would happen right now, right, is that device with PD will get PIO, will form an address, and will also use PD. Obviously, if the device keeps using addresses formed from PIO, we basically do not have any of those benefits I mentioned before, right? Because those addresses from directly connected /64 will consume network resources. So it would be highly desirable if device which can do prefix delegation uses prefix delegation and ignores PIO completely. Next slide, please. And obviously I can't remove a flag because I want to support legacy devices, at least in some segments. So it basically means that what we want is for the network to be able to signal, hey, I'm concerned about my resources, so please use PD. And in small networks like home networks, it should not happen, right? So the client should not be trying using PD, even if the router, as Tim proposed, delegates the prefixes on request, right? So we do not want this to happen by default. So also we want the prefix delegation capable device to ignore PIO and do not use addresses from PIO. We theoretically can start PD, get address from PIO, then when PD completed, remove addresses formed from PIO, but that would be very intrusive for an application because some applications will be using the address, so you either need to do it gracefully or interrupt the application. Next slide, please. So proposed solution for this problem, which is in scope for 6 men, and the draft will be hopefully will be submitted today, is to introduce a new P flag in PIO. So basically it tells the host, if P flag is set, ignore the A flag, don't do anything, don't do Slack on that prefix. Start PD, get your PD, and use those addresses to form whatever addresses you need. So, next slide, please. So, as far as I know, we have Android implementation in progress. So basically, working implementation. And we'd like to ask for working group adoption if people think it's a right thing to do. At least if the group think it's a problem worth solving.
Jared Mach, small ISP operator. I only give out a /60 to my customers. I'm not going to justify why to this room because I don't need to as a network operator. But one of the trends and one of the challenges of IPv6 is there's so many ways to do everything. I have a number of technologies and methods and techniques to get an address. And when you talk about DHCP v6, it's amazing. I can support 32 different relays, as the intermediary. Heaven forbid if you have more than that or want to look at what the first one was. But when we look at this and how this might complement the other drafts and documents that are presented earlier today, what's not clear to me is how are we intending this protocol to actually be used to do things? For web transport, V6, all of the privacy addresses, the rotating of those, I understand the utility of this. With this, now you're going to make the devices more trackable because they're going to go and get a stable V6 address, a /64 per device, and that's going to be great for the companies who want to go and engage in end user tracking behavior and stuff like that. It is also going to make things a lot more complicated for anyone who's trying to do anything else. And there's cases in the enterprise where you want to have device level accountability, device level access controls. And I think that what we are dealing with here is an existential question, not about the tracking or any of the things, but we have so many ways of doing things which work great for a web transport, but my SSH sessions, I can't keep a SSH session open with my server for more than a week. Why? My server, my machine rotated off the privacy address and I can't use it anymore. And I may want that on my specific host workstation, but to go and reconfigure them all to go and do this is an issue. So my question to you, Jen, in part, but really this is more of a question to the working group, to the chairs and the AD, is how many ways do we want V6 to be able to select an IP address? Because there is a host of proposals that are out there and a host of IP addresses that end up on these devices, just a ton of them. And whether or not a device is a proxy gateway or is a router, I think is irrelevant. I think the question is, how do we want to get these addresses and how many different ways do we want to support? Because as an ISP, how many do I need to expect that my end users are going to request from me? I'm not likely to change, from now, because I've gotten that deployed. And I think that's something which we've yet as a community have not come to true consensus on, because Slack, DHCP, I don't know, there'll be a new one that someone will think of next week. And we need to figure out what is the long-term way we want to do this, not what is the next micro problem that we think needs to be solved.
Well, let me use last in, first out approach. So to your last comment, I don't think it's a micro problem, right? I promised myself I'm never going to participate in Slack versus DHCP discussion anymore, and I made my promise like 10 times. What I'm trying to do here is actually close this discussion. Here is the benefit, the same benefits you're getting from DHCP, but you still let a host to select as many addresses as it wants.
Sorry.
I would love for us to pick one and be done with it.
Okay.
Yeah, so also, I'll try to be quick. I'm not going to answer all comments you made here. What I'm saying is we are actually not inventing the new way. The host will still use Slack. I'm not changing the way you get the prefix. PIO versus DHCP, and it's not new way, it's a known protocol, it's standardized protocol, right? It's nothing new here. It's just a combination of existing things we already have, how we implement them in the network. And you as an operator, you don't have to do this if you don't have scalability issues, right? You don't need to change anything.
No.
Okay.
I'd like to ask all the commenters to be concise. Also, Jane, you don't need to respond. You just listen.
Oh, great. Oh, nobody told me that before.
David Lamparter. So, limiting myself to the most important comment, there's a very subtle change in semantics here for the ownership of the addresses. Before with Slack, the address is owned by the interface, and now with PD, it's going to be owned by the host. I don't know if that's a good thing or a bad thing. I'm tending towards a good thing. I'm not sure. I just want to raise this and see what everyone else thinks about that specific small bit.
Okay, thanks.
Tim Winters, QA Cafe. I have two comments. One of them is you don't talk about IANA in the draft. You should probably tell people you probably don't want to be asking for that too, because that's what most people will do right off the bat. They'll ask for both, and you don't want to be. I think you just want to say, hey, this IANA, you shouldn't be asking for it as a host if you're asking for the PD.
Yeah, okay, yeah, we probably should make it clear. Yeah. We're kind of talking about PD, and I keep in mind.
Yeah. Okay.
Yeah, okay, thanks.
And the only other thing I would say is think about a little bit, you're going to have to put some text in here about host to host. When they both get two separate PDs, they're going to go right to the router, and that's going to get confusing. So you're going to want to add some hairpinning text or solve this in some way.
I was supposed to, probably I forgot to because Fernando was talking about it. Yes. Yes.
Yeah, sorry, I just supplement for the implementation and for the question from the first ISP guys. So you mentioned, you mentioned that you have some SSH maintainers over the web authentication, maybe just for 1 week. So actually for this idea, we also implemented the renew and rebind messages. So that's the extended lifetime address. So I think that's not a problem for here. Yeah, that's for the supplement for this.
Yeah, and yeah, thanks for reminding me. We actually I looked at the draft. We basically say you can do something similar to temporary addresses. You can rotate the prefixes if you want.
Cindy, and actually, first, I strongly support this draft. That's very good. And also actually in our lab, we have doing this assign/64 for several hosts. Each host gets one more than 1 year, so that's good. And the last comments I would like to say is, if we use IPv6 in the same way as IPv4, actually lots of new technologies not needed, but we should use IPv6 in a different way. Thank you very much.
Fernando.
Hi, Nick Braulio.
Yeah, hi, Jen. Can you hear me?
Yeah, Fernando, go ahead.
Okay, so I have a few questions. So, for example, one is, what if you were to need like a host were to need like, let's say, multiple /64s because it wanted to extend IPv6 to multiple segments. Would it be allowed to request multiple /64s? Would it be allowed to request just one? That'd be my one question. Yeah.
Yeah, I don't think it's actually a problem, because what I probably should have mentioned in the scenario when I described when we're migrating the network to V6 only, I realized I have to run PD. I basically don't have a choice because people are plugging devices which needs to expand the network behind it. So it's basically inevitable if you do not want to break your deployment. So yes, like we just basically, we're not introducing anything fundamentally new. We're just saying, oh, it's not a corner case of a router plugged to your network. Any devices can do that. So I do not see a problem here. Yes.
Another question is, let's say that a host were to request do PD, try to do PD, and for different reasons, like let's say the local router were to run out of prefixes, or it just doesn't support PD. Would it be the fallback? Is it Slack? Is it DHCP?
Well, we probably.
Yeah,
no, like
I'm coming
I think
from the premise, like, yeah.
Yeah, like, well, what's happened now if my DHCP-v4 server runs out of addresses in the pool, right? Nothing good, but I think in this case, we can actually say, if you're not getting PD because server is down or because something else, your host might either fall back to Slack, or we can say it's a network outage, the same way we're doing it with V4, right? Go and expand your pool or find out what's happening. So this is not worse than we have in V4 currently.
Jane and Fernando,
My question is,
to take the issue to the mailing list. We really need to move on. Edward, now we are supposed to use a mobile phone to join the queue instead of just coming to the queue. I noticed that maybe
it doesn't
a
work. I mean, IT problem
here,
doesn't work. I could not connect properly to the web server. I could not connect online.
But anyhow, we need to move
Edward,
on.
we can
Maybe
take it offline, right?
You
We
talk
can
to
talk
Jane,
in the
privately.
So I just emphasize could chairs issue the adoption call if they think it's right
Yeah,
thing to
it
do?
seems like there are plenty of interest here, so we will take it. Nick. Go ahead.
All right. Hi, I'm Nick Braulio. I'm going to present on a draft we've been working on that highlights the IPv6 site connection to many carriers. So basically, multi-homing IPv6. This is informational, not really trying to solve any problems, just highlighting what's available there now because it's sort of hard to find any place where this is all put together. So next slide. The problem is pretty well traveled. Everybody in this room knows what it is. It's basically, internet redundancy for IPv6 when you connect one location to multiple providers. As you can see in the diagram there, carrier 1, carrier 2, they may have walled garden services like DNS where you can't get to one, you can't use those services from outside of their network. Totally expected. It's all over the place. The goal here is to sort of highlight, things that have changed in that, site resiliency is much more important now than it was, 5-10 years ago. The idea of having full connectivity in any given location is a lot more similar to, the electricity working than it used to be. So with IPv6, that's a little bit of a difficult task to scale when you don't have resources or if you may not have the ability to do certain things like PI address space. So what we've done is really laid out like what you can do. Next slide. So this is sort of in increasing levels of desirability and complexity. So the PI-based solution, this is the most common one. It's if you have your own address space, ASN, you connect to multiple providers. Everybody knows what this is, right? This is what all the large environments will do because they have the resources to do it. And I'm not going to go through all of the details of each of these because everybody really knows what they are. But we lay out the advantages and the disadvantages of each one, right? This is an obvious one. Next slide. This is where it very quickly devolves into hard and less fun. So as soon as you get into a situation where you have a provider assigned addressing and you have multiple providers, it doesn't really even matter what your CP is, how many of them there are. It just becomes very difficult to lay out the addressing in a redundant manner. So this is an option. We've made it work. It's very complex and it's very clunky, to be quite honest. Next slide. And actually, if we think back to the last slide, a lot of these things will work much better if you're not also using IPv4, right? You simplify things in an IPv6 only environment, but the types of environments that these are getting deployed in, that's really not an option as much as it would be nice if it was. It just isn't done that way. So second option would be to use ULA with NPT. This has all the well-known baggage that goes along with ULA, not being able to change the preference in your clients, in some clients, and being preferenced below IPv4. With the implementation of NPT, this actually works with an IPv6 only environment, but again, when you put v4 in there, things fall apart quickly. And the final option, next slide, please. ULA plus NAT. Obviously, this is the least desirable of all of them because it breaks things that we don't want to break, but it is actually deployed in the wild, and so it should probably be noted that it is actually something that is doable. Next slide. So we laid out a map with the solution considerations and just sort of put it out there for people to use. Next slide. So this is really the most important one. That the IPv6 has a lot of operational issues to work out, and multi-homing when you don't have PI address space in an ASN is sort of an elephant in the room because that's a very large percentage of deployments. And sort of a side effect of this, other than just pointing out here's what you can do right now. Again, not trying to solve any problems, just laying out what's currently available for a random end user or technical person to use. But one of the side effects is sort of pointing out there's a little bit of a lack of flexibility and options in this space. And yeah, that's really it. Pretty straightforward.
Tim Winters, QA Cafe. So real quick, two things I thought about this one. One of them, you didn't talk about, and in your picture you have ULAs in it, but the routers have to agree on what those addresses are. You're in the same mess, even actually a little bit worse. So that might be something you should probably put some text around. It's just making sure those routers agree, which they never do. Thanks for doing this, as someone who's tried to explain this many times, and I dodged this in the draft we just talked about because this is a very hard problem. So I think this is a great place to start writing down what our options are.
Thank you.
Hi, Eric Vink, as the author of RFC 8801, which is the PVD, provisioning domain. I think you should mention a solution there with the PA and the PVD.
Okay.
That's a good job.
Noted.
Tolle Eckert. Yeah, thanks for the work. I mean, the issue I saw with the table was that who's making up these criteria and who's making the judgments, right? So I saw, for example, nothing about the positive things that I can get with PA addresses, right? That I have, the ability to pick, which part of the network I want to enter based on address selection, right? Positive things, right? It was all coming from, probably your view that, provider independence is great. I like it. So everything else scores fewer plus points, right? Which is a perfect, opinion, but I think maybe other people have other opinions, or people that know they will not, be able to get provider independent addresses, like most of us at home, I would guess, may also want to see other positive criteria, right? So in the first place, the question is, how do we come up with all the criteria and agree on them if we want to progress with them in the working group?
That's a great idea, and we will do some work to add some of that text. Now, I will say that most of the testing that I did was centered around PA. I know PI works, right? I've been doing that forever. I know that works. That's the solved problem. The PA stuff is what I spent the most time around. So that's a really good suggestion, and we'll work on that.
Yeah, Lorenzo Colidi. I mean, I think it's worth noting that I think, as far as I can tell, NPT is experimental and that is not recommended. So from an IETF perspective, the ULA and like private address solutions aren't really something that we can endorse, right? Because they're experimental or actively discouraged. So yeah, I mean, we know that multi-prefix multi-homing is hard, but we need to somehow make progress on that problem with global space.
Well, so I think it's really important to say out loud, this is not an endorsement of any of the technologies. It's simply a document that says these exist and people use them now. It's absolutely not an endorsement.
Hi, Xin, BOPT University. Thanks for this work. Anything else?
I'm sorry, I was distracted.
I heard somebody else say something. Thanks for this work. It's a very good start. What I would like to emphasize is not only the PA address important, also there are still a lot of operation issue for the PI address as well, particularly for how to use them or tell them between multiple providers, and those providers also will filter the packages, use the address from other providers that actually create a lot of issues. I would like to see you to include in those analysis and how to operate on them in the future version. Thanks.
Okay, we did put down a little bit of information on the not being able to use one address space down another provider. We can expand on that a little bit. People think that's a good idea.
Okay, thank you. Let's move on.
Hi. Hi, I'm Amoka from Tokyo University. I'm here to present a draft IPv6 only capable resolver utilizing NAT64. So next slide, please. So the motivation of this draft is we have a small IPv6 only AS, and we wanted our own iterative resolver. We wanted our own DNS resolver, and we wanted to run it IPv6 only because we have an IPv6 only AS. So we thought that would be normal. But it turns out we can't fully have an IPv6 only iterative resolver because of IPv4 authoritative service. And I think most people who are wanting DNS resolvers have an IPv4 address on them currently. And I don't think many people have IPv6 only iterative resolvers. And I'm proposing this informational draft to say that if you utilize the NAT64, it is possible to have an IPv6 only iterative resolver. So this is the left bottom is the topology we have. So the IPv6 only iterative resolver is inside the IPv6 network, so it does not have an IPv4 address. So a proposal is for the IPv6 only resolver to use the IPv6 to IPv4 translator, the stateful not DNS, the stateful not 64, and connect to the authoritative server. So if you look at the diagram on the right bottom, you can see how an IPv6 only iterative resolver may fail to resolve domain names if the zone is contained by an IPv4 only authoritative server. So next slide, please. So we propose an IPv6 only capable iterative resolver. And what it does is, if there is only an A record for an authoritative server, the resolver performs address synthesis to the IPv4 address of the authoritative server and make it IPv6. So it applies the pref64 to the IPv4 address and construct an IPv4 converted IPv6 address as defined in 6052. So this way, the resolver can send an IPv6 packet and it will be routed to the NOT64, and then we can connect to the authoritative server. Next slide, please. So why we want to do this? As I said before, we want to take away IPv4 addresses from iterative resolvers. And I forgot to say why this draft is talking about iterative resolvers. So all other services, all other clients can't use domain names. So if you're under a NOT64 DNS64 environment, you can use the DNS64 to do the translation for you. But an iterative resolver cannot utilize a DNS64 because, for obvious reasons, the DNS64 needs to be somewhere, and a resolver cannot ask a resolver for something because that's just weird. So what we have a problem is that we think that there's a lot of IPv4 as a services, and having an IPv4 as a service solution may be great, but some people are using DNS64, not 64. And if you're using DNS64 and not 64 to provide a IPv6 only network, you need to have a solution inside the iterative resolver to be able to connect to the authoritative server. So yes, so this is a proposal, and we have I presented this at London last time, and after that, I think I had good feedback from the room, and I think I also had like multiple feedback in the mailing list saying that it's good. It's good to be documented. So next slide, please. My question to the room, oh shoot, I forgot this slide. So there are implementations. Mark Andrews has his pull request in bind. David has his for unbound. So they are implementations. They are not merged to the main branch. So I don't think many people are using it, but they are implementations. So next slide, please. So the thing I want to ask the room today is this worth documenting? Is this like, because if people think this is a waste of time, I will stop coming here and talking. But if people think it is nice to have a document saying that you can have an IPv6 only authoritative server even when there are still a lot of IPv4 only authoritative servers. So this is my question to the room.
Okay, Eric Ving, no head or whatever. Did you present this to DNS op as well?
No, I haven't.
I think should be nice. Else, very simple stuff, but simple stuff needs to be documented as well.
Sorry, what did you say? In the last sentence.
So sorry. When I say simple stuff, right, but needs to be documented, so should be published as a draft, or it's an RSC basically.
Okay, thank you.
Hi, I'm Masanobu from NEC Platforms. It's okay now? Okay, thank you. I'm Masanobu from NEC Platforms. Could you explain your expected use case, or like a HomeNet or enterprise or data center?
Okay,
What's
so
your target?
our target is, so that is a good question. So we are operating a small IPv6 only AS for experimental use. So we do not have knowledge of ISPs or like those stuff. So I don't know if they will be interested. I think they have IPv4 address space, so maybe not. So another thing is not operations, but for people in home networks. People who have home networks, they can ask their ISPs resolver, or they can ask an open public resolver, but they might want to operate their own resolver at home. But there's a lot more home networks that are IPv6 only, and I think a lot of people might want to have their resolver at home. So yeah.
Okay. Why don't you use a CRAT in the host or server?
So that is a great question. So my draft is for people who don't want to use a CLAT. I think why not use a CLAT is a great question, but
Okay, anyway, maybe we should clarify this kind of use cases.
Okay.
I will support this.
Okay, thank you.
Rafael Akamai. So the question was kind of like, you presented at Dina's work, and it wasn't clear if CLAT would work. Have you now did some experiments with CLAT? Would it work if the host had CLAT, the V6 only resolver?
Yes, because if there was a CLAT, it will use IPv4 packets.
Okay, good. So thanks.
Okay, so thank you.
Thank you. Right, Sam.
Okay, can you start?
Yes, it's already there.
Okay, hello, okay, okay, hello everyone. Today I will talk about IPv4 and IPv6, their stack migration for, okay, how to use it? Okay. Sorry. Hello, everyone. And today I will talk about IPv4 and IPv6 and their stack migration for in-house software load balancer in private cloud. Nice to meet you. Okay, next slide. So let me introduce about myself. My name is Rei Shimizu, and I'm working as a software engineer for Applying Corporation, and especially I'm focusing on developing in-house software load balancer in the private cloud. And before joining Ryan, I was working as a OSS developer. Especially, I was focusing on HTTP proxy and several softwares for constructing distributed systems. And so as you can see, this is the first time to join IETF. Okay, so let me introduce about our services. So Line is known as a large-scale messaging service, but we have a lot of services, not only messaging services, but also messaging, fintech, and healthcare, and entertainment, and so on. So also, we have many users, not only in Japan, but also in foreign countries. So the requirements for our network infrastructure for our services are very wide. Next slide. So this presentation is mainly focusing on IPv6 operation. So, and the IPv6 requirements is only for messaging service. So let me introduce about messaging service for more detail. And so why messaging is one of the core products at Wine Corporation. And this service is used by many users as for several countries, including Japan and Taiwan and Thailand, and also Indonesia. So as for these countries, so we have a lot of MAUs. So we receive a lot of traffics from these countries. Yeah, next slide. So let me introduce about Berda quickly. So what is this? Berda is a private cloud platform at Wine Corporation, and it is used by many developers at Wine Corporation. And also we have been hosting a lot of services in this platform. And as we grow the company, so we have many services in this infrastructure. So, and it's so that it provides a high level abstraction of compute and network and storage resources. So also we have many number of virtual machines and physical machines and so on. So Berda is one of the largest private cloud platform in Japan. And also, it provides many services which supports service development, for example, CDN and Kubernetes and Kafka. Next slide. So let me introduce about Berda LB. So Berda LB is one of the network service provided by Berda. So, and it is one of our oldest service in Berda, and it's like GCP's cloud load balancing or AWS LB. So Berda LB is one of the core components to introduce IPv6 for our services. So let me introduce about Berda LB for more detail. It is designed by focusing on scalability and performance. So and currently, it provides both two types of load balancers. First one is L4LB, and second one is L7LB. And so IPv6 operation is highly related with L4LB. So I will introduce for more detail about L4LB in the later slides. But I will provide little information about L7LB because it is not highly related with IPv6 operation. Next slide. So let me introduce about L4LB internal for more detail. Berda L4LB is completely software-based, and it has been developed from scratch, both control plane and data plane. And the L4LB uses IP encapsulation for upstream traffic. So the L4LB doesn't do any address translation logic like NAT. And the return traffics don't go through L4LB nodes. And so we are using a mechanism called L3 direct server return. In short, we are calling it as L3 DSR. Of course, it supports both IPv4 and IPv6. Next slide. Okay, let me introduce about networking infrastructure for Berda. So our data center networks are constructed with a cross network. So cross network is composed of several components, including wave switches and spine switches and top of rack switches. And so all the parameter nodes are connected under top of rack switches. So and all the traffics are balanced using ACMP. So it is relatively easy to scale network capacity as users' requirements. So the one of the characteristic feature is that we are using a full L3 network. So it means that all the components, including switches and parameter servers, speak BGP to advertise their routing informations. Next slide. Okay. Why we decided to use IPv6, even though we have been operating a wide scale IPv4 only network for years. So it is due to the requirements from ISP in Taiwan. So as I said, we have many users in Taiwan as for wide messaging application. So actually, IPv4 single stack network is not desirable for large-scale content provider because it forces many ISPs or mobile carriers to force using IPv4, even though many of them are using IPv6 network. So if we still provided IPv4 only network, so we would force them to use coexisting technology like NAT64 or DN64. So supporting IPv6 is also desirable by a large-scale content provider. But the requirements of IPv6 is very limited because it is required by only messaging services. So, and we don't have large motivation to construct IPv6 only network. So at the moment. So, and also we would need to support IPv6 for all the services if we provided only IPv6 only network. So it was a relatively high cost from the perspective of service developers. And so we didn't stick to provide IPv6 only network, and we decided to use IPv4 and v6 dual stack network for step-by-step IPv6 migration. Next slide. So this is a network architecture about our corporation. So our services are used by several countries, and we provide multi-region. So therefore, we have many data centers in several countries. So of course, cross networks are located under several data centers, and it means that L4LB nodes have been distributed around all the data centers. So we have been maintaining legacy network, so also in several data centers. So, and as I said, we don't have to introduce IPv6 for all the networks. So actually, we introduced IPv6 only for backbone and several several networks. Next slide. So L4LBs are located on several top of rack switches in cross network. So previously, L4LB itself advertises virtual IPs to the cross network. And to support IPv6, we changed to advertise IPv6 virtual IPs to top of rack switches. But all the L4LB nodes don't have to advertise both the type of IP addresses. So it was relatively easy to introduce IPv6 thanks to for L3 networking approach. Next slide. So how to change L4LB data plane to support IPv6? So we had two approaches. First one is when the L4LB receives the IPv6 packets, then it forces to for the traffic and by encapsulating IPv6 packets. So it is called as IP6 in IP6 encapsulation. And the second approach is not to use IP encapsulating by IPv6 packet, but encapsulating with IPv4 packets. So it is called as IP6 in IP encapsulation. So we should consider about which approach is better for our use case. Next slide. So at that time, many services were running on the IPv4 only network, and as for line messaging was not also an exception. So, and if we use IP6 in IP6 encapsulation, so service developer must support IPv6 network. So also our LB system requires DNS resolution because it supports to register real servers to load balancer with FQDN. So, but the resolution mechanism is developed only for a record, and then we don't have IPv6 support for our internal DNS service. So the development cost would be been relatively high if we had been used IP6 in IP6 approach. So this is why we decided to use IP6 in IP encapsulation approach. Next slide. So, and we shouldn't forget about PassMTU discovery for IPv6 network. We are using encapsulation approach for upstream traffic. So client must send packets shorter than upstream MTU. So to achieve this requirement, Delta L4LB is supposed to send ICMP 2 big packets to client for PassMTU discovery after it receives packets rather than upstream MTU. So in this example, the upstream MTU is 1,500. So the downstream MTU should be 1,480. And the L4LB supports both TCP and UDP. So we can use MSS clamping for UDP use case. So for IPv6, we changed to respond with them by sending ICMP6 to big packets. So I showed this slide that our data center network uses 1,500 MTU, but we are using higher MTU size in newer data center network. So the relatively low MTU is only in legacy and old cross networks. Next slide. So we did step-by-step migration to dual stack network. As for load balancer, we are afraid of migrating to dual stack network immediately because we couldn't know whether the IPv6 network capacity is enough or not. So as for load balancer, our approach was to prepare IPv4 and our approach was to prepare both IPv4 and IPv6 L4LB nodes. So to minimize the burst radius of IPv6 migration, so we want to increase the ratio of IPv6 gradually. So fortunately, we are using FQDN to provide virtual IPs. So we configured the ratio of responses of DNS queries with A or quad A record, and then we can control the amount of IPv6 traffic. So also, we used ZSLB by Akamai to control the ratio of an IPv4 and IPv6 for each AS. Next slide. So finally, this is the final architecture of wide messaging service with IPv4 and IPv6. So we supported dual stack network only for front-end network, but we continue to use IPv4 only network for back-end traffic. So, and also we have several front-end applications named Regi and OBS. So, but these applications no longer to support IPv6. So our approach was relatively reasonable from the perspective of service developers. So, but we should consider about using IPv6 only network in the future because IPv6 addresses are being in consumption and the price of them is very high. So at the moment, next slide. So this is the bandwidth of traffics to Regi in a day. So wet one is IPv6 traffic. So as you can see, so every handles many IPv6 traffics. So it is approximately 50% of them. Next slide. So I told about Delta L7LB little in the introduction of load balancer. So, but we don't have IPv6 support L7LV. The reason of this is that the performance of the L7LV is relatively lower than L4LV, and so L7LV is not used for applications which requires a high, massive traffic capacity. So IPv6 is required only messaging application. So we don't have a support IPv6 for L7LV. So we made these decisions by using service-oriented conservation. Next slide. Okay, what we run for dual stack migration for build a load balancer. First, supporting IPv6 for in-house software load balancer is relatively reasonable thanks to service highly distributed architecture. And the second one is that we introduced IPv6 features quickly because it was created by software. And the third one is that service-oriented conservation may be the best first step for IPv6 migration by contents provider. Next slide. So these are the reference slides, and several slides are written in Japanese. Okay, next slide. Okay, thank you for listening.
Any comments, questions? If not, then we end our session on time. Thank you all very much.
又回来做这个 IPv6相关的。